Hello, welcome to this video about constraint optimization. In the last video, we talked about unconstrained optimization. In that case, we had two variables, v, the velocity, and L, the length. And basically, these variables could attain any value. And what we did was search for the best combination of values, but there was no restriction or no constraint in the values that these variables could take on in principle. But there are cases when this is not the case. And if a variable cannot take any value that you want, but for example, there is a bound above which it cannot take that value, or if only a combination of two variables is possible, then we talk about constraint optimization. To fully tell you about this, to fully explain it, takes a little while, so keep on watching the videos. This is an example of constraint optimization, but again, it will be more clear in the movies to come. Here we have an upper arm and a lower arm. The upper arm is connected to the world, it's steady, and the lower arm can rotate. But it doesn't rotate because it is in equilibrium. Because of the forces that are working on it. We have a force of gravity, that's here, 20 newtons with a moment arm of 15 centimeters. And we have two muscle forces that balance the lower arm. So we have a muscle force Fs1 with a moment arm of 0.02 meters, 2 centimeters, and a green muscle force has a moment arm of 4 centimeters. Okay, this should be a very familiar problem. In the course biostatics, these kinds of exercises have been done frequently. And what we did was to write down the equations for equilibrium. So what we have here is the equilibrium of forces in the horizontal direction. Well, there is only one force because there's also a force in the joint. That's a bone-to-bone contact. And there's a horizontal component Frx and a vertical component Fry. And the Frx is the only force that is applied to the lower arm. So if you want to have equilibrium, then it should be 0, as this equation tells us. Now for the vertical direction, we have Fry, but we also have the force of gravity. And if you add these like this, then they should also equate to 0. Well, and that gives us the solution for Fry, namely 20 newtons. So far so good, this is very easy, but now what we are going to do is take the sum of the torques, the sum of the moments. And there are 3 torques working here, so we take this as the torque center, and then the force of gravity is applies a moment of 20 times 15 centimeters, and that is clockwise, so we put a minus sign over there. Then we have two forces, Fs1, Fs2. Fs1 has a moment arm of 2 centimeters. Fs1 times 2 centimeters and Fs2 times 4 centimeters. These are the three torques that are applied. And if you look at this equation, well, of course, if you add them, they should be 0. So here we have one equation, and we have two unknowns. Fs1 and Fs2 are both unknown. And this is different from what you have encountered before. Because now we have a problem because we have one equation and two unknowns, and that is unsolvable. That is to say, the problem is not that there is no solution. No, the problem is that we have many solutions, infinite many solutions, in fact. So what I'm going to show you is one of these infinite number of solutions, and that is Fs1 equals 50 newtons and Fs2 also equals 50 newtons. Now what we are going to do is to substitute these values into the equation and then check whether the equation is correct. And by correct I mean that the left hand side and the right hand side are the same. Okay, so we start by the moment of the force of gravity. Then we substitute 50 for Fs1, multiply by the 2 centimeters, and here we have 50 for Fs2, multiply by 4 centimeters, and that should be 0. Well, this is easy to check because 20 times 0.15, that equals 3 with a minus sign. Then we look at 50 times 0.02. Well, that is 2 divided by, that's 1. This is 1. And 50 times 0.04, that is 2. So here we have minus 3 plus 1 plus 2, and that of course together gives us 0. And on the right hand side we also have 0. So this way you can check whether this supposed solution is a correct solution. And well, as we have shown, this is indeed a solution. But the point that I want to make is that if you try another combination, and there are many combinations of Fs1 and Fs2 that are also solutions. And we will see that this is true in the next exercises. So thank you for watching, and I'll see you in the next video.